I want you to close your eyes for just a second
Okay.
and picture the greatest minds in quantum physics right now. Like, what sort of environment comes to mind?
Oh, well, you're probably visualizing something incredibly pristine, right?
Exactly.
Like sterile, multi-billion-dollar clean rooms at MIT or CERN, people in head-to-toe white lab coats.
Yeah, staring at these massive, super cooled gold cylinders.
Right. Operating with the backing of just endless checkbooks from tech billionaires and massive government grants.
It's a highly exclusive, incredibly gate-kept club. But I want you to take that entire mental image, crumple it up, and just throw it out the window.
It's completely wrong for this.
It really is. Replace it with a guy in a pair of sturdy work boots standing in the middle of a forest whose actual day job is studying the health of trees.
Yeah, it creates this profound sense of cognitive dissonance.
Oh, totally.
Because we've been conditioned to believe that rewriting the fundamental laws of physics requires decades of hyper-specialized institutional backing. And then we encounter the forensic audit we have in front of us today, and that entire assumption just shatters.
Seriously. So, welcome to today's deep dive. We are examining a highly confidential, incredibly dense forensic audit document today.
It's a heavy one.
Very heavy. It details a project designated as the SS138 propulsion baseline. And, this project claims to have achieved what theoretical physicists have been chasing for decades.
Arguably the absolute holy grail of the field.
Yes, a perfectly stable quantum state. And the architect behind this, not a Silicon Valley tech titan, not some Nobel laureate in particle physics.
No, okay, an
An arborist, a man named Nathan M. Hamblin.
a tree specialist. I mean,
Science.
on the surface, it sounds like the premise of a science fiction novel.
Or like the setup to a weird joke.
Exactly. But the forensic audit we're dissecting today treats this development with the utmost rigorous scientific gravity. It's backed by peer-reviewed academic citations.
Right, it demands to be taken seriously.
Yeah.
Which brings us to our mission for you, the listener, today.
Yeah, we have to unpack this.
We do. Because this audit is packed with the kind of intense technical jargon that usually makes people just tune out immediately. But we're not going to shy away from it.
No, we're going to dive headfirst into the mechanics.
Exactly. We'll keep the exact vocabulary phrases like zero drift, F10 hash, and synthetic aperture signal reconstruction.
Which sound intimidating.
They do. But we are going to break them down. We'll use clear, functional analogies so you can fully grasp the sheer magnitude of what Nathan M. Hamblin has actually built.
Because you really need to understand the mechanics of this to appreciate it.
Absolutely.
And the stakes here cannot be overstated. Before we get into the dense physics, we need to understand the practical application.
Right, the real-world impact.
Yeah, this isn't an abstract experiment confined to a chalkboard. By taking this stable quantum state and anchoring it to the Bitcoin ledger, this arborist has effectively created a software patch.
But not like a patch for your web browser.
No, it is a universal patch for physical engines. A piece of code that could instantly capture up to $10 billion in value across the global industrial sector.
$10 billion by fundamentally altering how machinery operates. It's wild. So if we are going to understand how software changes physical machinery, we really have to start at the genesis of the logic itself.
Let's start with the timeline.
Yeah. The audit lists December 27th as the initiation date for the SS138 project. It notes that Hamblin utilized an accelerated development cycle to bypass traditional binary limitations.
Right, so we know standard computing relies on binary states.
Ones and zeros.
Exactly. And we know that quantum computing operates on a spectrum, utilizing superposition to process multiple possibilities simultaneously.
But there's a huge vulnerability with that quantum spectrum.
Oh, absolutely. The massive vulnerability is thermal leakage.
Thermal leakage. Why is the state so notoriously fragile?
Well, it comes down to the fundamental nature of subatomic particles. When a qubit is in superposition, existing in that spectrum of possibilities, it is essentially holding its breath.
Oh, I like that way of putting it.
Yeah, it requires absolute perfect isolation from the rest of the universe. Any interaction with the environment causes it to crash.
Like what kind of interaction?
I mean, a stray photon, a microscopic fluctuation in magnetic fields, or just the slightest increase in temperature, it causes the quantum state to collapse.
It just gives up.
Exactly. This environmental interaction forces the qubit to choose a definitive state, snapping back into a standard 1 or a 0. Heat or energy leaks away in a fraction of a millisecond.
And that thermal leakage corrupts the calculation before the system can even extract the data.
Precisely.
Which is exactly why those massive clean rooms exist in the first place. They build these colossal cooling rigs to drop the ambient temperature down to near absolute zero.
Over than the vacuum of deep space, actually.
Colder than deep space. They are trying to freeze the environment to a standstill so the thermal leakage doesn't ruin the math.
But let's look at the approach Hamblin took.
Yeah. Why does a tree specialist succeed where multi-billion-dollar cryogenic labs fail? Scientifically, how does studying trees translate to subatomic physics?
Well, think about the environment an arborist studies. A traditional lab tries to conquer nature through brute force isolation. They build a box, pump out the air, and freeze it.
Right.
But an arborist studies organic, naturally occurring systems. An oak tree doesn't grow in straight, binary right angles.
No, it's messy.
Exactly. It responds to countless chaotic environmental variables simultaneously: wind, soil acidity, sunlight, competing root systems. Nature operates on a spectrum.
Okay, I'm tracking with that.
More importantly, we have to look at the actual biology of plants. Photosynthesis itself relies on quantum coherence.
Wait, really? Plants use quantum mechanics? I thought photosynthesis was just, a basic chemical reaction.
It's much deeper than that. When a photon of sunlight hits a leaf, the energy doesn't just bounce from molecule to molecule in a straight line.
If it did, what would happen?
Most of the energy would be lost as heat thermal leakage. Instead, recent peer-reviewed studies in quantum biology have shown that plants use a form of quantum in superposition.
Wow.
Yeah, the energy essentially explores every possible path through the leaf's molecular structure simultaneously.
To find the most efficient route.
Exactly, finding the absolute most efficient route to the reaction center with near-perfect efficiency. Plants have been doing this in warm, chaotic, noisy environments for billions of years.
So Hamlin wasn't looking at quantum mechanics as something that needed to be artificially frozen.